Okay guys, follow up on my son's Toyota Celica. I've got lots of comments from you guys about the clips that we showed with the cold start injector spraying all the time and the regular injectors not firing. And then I had some guy that was like, you unplugged the vacuum hose and you're lying to us. No, I unplugged the cold start injector. So starting with the cold start injector, I had some good comments from you guys. One was someone had mentioned Toyota typically color matches the connector and that I probably had the wrong connector connected to this, which I think you're right. I think whoever said that is right. I want to show you the checks I did on this, that it could actually be this connector that I don't have connected to anything. This may be my cold start injector wires. In fact, let's look at colors because I have not done that yet. I got a black and white, and then a green. This one, I don't know the colors on. These get pretty dry rotted. So black and white and green. Let's go look real quick. All right, so in this time switch, where's the injector? Okay, injector's up here. I have a green and a black on the cold start injector. However, that black wire, if you follow my finger, is tied into black-white. So the fact that it's black-white on the car, it's a manual transmission as well. Yeah, it says black for an automatic, black-white for a manual, and then it shows it turning to black. But it being black-white over there, very likely that is my guy, okay? Let's go back to the car. So when I tested this one to make sure that it was the cold start injector, I knew that the injector would only get power during cranking. So I have my test light. We're gonna do that check real quick. Test light connected to ground. And then we're just gonna touch on these two wires while I crank it over. And I'll have Caleb, can you one hand this, Caleb? Will you be able to touch on that? What we need is Beau. Should I get him? Yeah, let me get him because we're gonna need him. So while we're waiting for Beau, this wire right here comes from the ignition switch. This is operation of this cold start injector. It is not a computer controlled circuit. This would be hot in the crank position. No neutral switch because that's automatic. So straight through, comes up this way, goes to your starter S post. This is the S post on the starter. When's that get hot? Only cranking. That same wire is shared with the circuit opening relay, and it also triggers the engine computer that you are cranking it. And then from there goes to our start injector time switch, the thermo time switch, as well as the fuel injector itself. The point here is, when does this circuit get power? Only during cranking, okay? And then the ground of the injector is controlled by the time switch. Your key right now is in the on position because I have it on. But what I want you guys to see first, this is the circuit I was testing. I got nothing here. I got nothing here, okay? Nothing. Go ahead and crank it, Beau. Okay. Again. Okay. As you can see, that circuit is only hot during cranking. So right away, my assumptions on that, okay, no problem. This is my injector plug. Let's check this one now. Crank it. Okay. Same with this one. Good. Crank it. Okay. Crank it. Okay. So why did that one glow during cranking with it unplugged? Will we get a back feed with the injector unplugged? We would. Okay, that second connector I checked was hot cranking, and with it, the injector's unplugged, it was glowing dimmer on the other wire. If the injector's unplugged, that is possible if that time switch is not being grounded, that we could get a back feed. Okay, let's get this running. We'll plug this guy back in that I had plugged in. Go ahead, Beau, start it. All right, this circuit is hot with it running. It should not be. That's why it was spraying all the time. This one, good. This is I had the wrong connector. That's my injector plug. Shut it off, Beau. So your injector was spraying all the time because I had it plugged in wrong. Okay. The one that I had plugged into that, I believe, is for the EGR system. I'm not totally sure on that, what this other one's for. Yeah. We'll have to let this cool off to finish checking this time switch and make sure it's functioning properly. But the way that this works would be, as you're cranking it over, this is thermo and time, two words, meaning temperature and time will control this ground for this injector. The injector gets grounded through that switch right there on the time switch itself. So two things will make that bimetallic switch close. One is when coolant temperature is below 35 degrees Celsius, which I believe is around 100 degrees, roughly, right? 100 degrees Fahrenheit, 90 some degrees Fahrenheit.
That'll make the switch.
If the coolant temperature is warmer than that, it will warp that bimetal switch and it will stay open. It will not be closed. So it will not ground that cold start injector on a hot start. That's the point. You don't need it on a hot crank because you don't need that extra fuel. So when coolant temperature is above 100 degrees, it will warp that bimetal switch, it will open the ground. The second thing that will make this open, let's say it's 10 degrees outside, and there's something wrong with the car, maybe the ignition system is messed up, and you're cranking and cranking and cranking and cranking, right? Doesn't start. You crank, doesn't start. You don't want to continue spraying this cold start injector every time you crank the engine over. Remember, it's 10 degrees. So what they have inside of here is a heating element. As you're cranking it, this circuit, it splits. So your power feed right here splits, and you have, not only are we powering the injector, we're also powering this coil, this heating element that goes straight to ground through here. So every time I crank this engine over, we are heating that element. So what you have is basically an 8-second time limit. You will only have 8 seconds of fuel coming out of that cold start injector before the heating element would heat up enough to open the bimetal switch, even if the coolant temperature was 10 degrees.
So regardless, it's really temperature that opens the switch either
way. It is temperature that opens the switch either way. It's time for the time switch, the thermo part, the electric part, to heat it up and warp the bimetal. So if it's really, really cold, you're gonna get more of a spray.
Is it like an actual mechanical switch, or is
it is an actual mechanical switch that's internal. It's a bimetallic, two pieces of metal that are not melted together, but two different metals. When you heat them, because they're two different metals, bimetal, it warps it. One will heat more than the other and it pulls it, warps it. So it's a mechanical piece. That's it. That is your cold start injector. The reason why this injector was spraying all the time is I had identified a crank circuit, but it was also hot in the run position, and it should not have been. It was the wrong connector. It was probably, I think, for that EGR valve, because there's a solenoid that I'm missing. It's not even plugged in right now. And then, so with the injector unplugged, the fact that my test light was glowing tells me that there was no ground here on this time switch. We may have a bad thermo time switch. So yeah, we still need to check this time switch, but I need to let it cool off, which is why I had Beau shut the car off, right? So we can check this ground for this fuel injector. For this one, I'm gonna wanna keep it plugged in, just so we don't have any kind of backfeed. So let's do that. I'll plug it in and we'll check the tan wire, sorry, not tan, on our car. Plugged in, we'll check the green wire, which is the ground. The black is the power. So we'll plug that in. All right, I'm gonna do this a little different just for ease of troubleshooting. Test light to battery positive. This should be grounded right now. It is, or it's being backfed. Let's see, let's make sure we're not getting a backfeed.
Which wire are you on?
Green wire. So I'm getting a little bit of a backfeed through the starting circuit with the injector plugged in. This should be grounded. Yeah, this is gonna be a little bit difficult for you guys to read. Okay, the dimness of that is concerning for me. I want this to not start, so let's take the ignition out of the picture. That way we have no RPM input, so my injectors aren't firing, my spark is Not there either. Crank that over, Beau. This should disappear. This light should disappear. Go ahead. Okay. Crank it again. Okay. So there is no ground at all. That's also feeding through this time switch circuit. If I would disconnect the starter S post right now, this light would go out, is what I'm saying. We have no ground for this thermo time switch right now at all. So this might be a problem where this doesn't start cold. We'll have to come back to that after this sits for a bit. But my main purpose today was, well, to address those things with you guys. But when Beau and I drove this, it ran good for the first 10 minutes and then started running very poorly. And what I noticed coming out of the tailpipe was a massive cloud of black smoke. This being an older system, the only thing that I can get out of the engine computer is trouble codes, like flash codes, and then the rest of it is all manual tests. So there really isn't a whole lot that'll make this engine run rich as far as the sensors go. You really have your throttle switch, your throttle sensor, your mass airflow, and your coolant temp sensor, and all three of those we can check very quickly. So my plan was to look at the MAF signal, look at the ECT signal, those two primarily. We can take a quick look at the TPS as well. So starting with the coolant temp sensor before it gets too hot. All right, so we got a green and a brown. Let's make sure that that's my coolant sensor. Water temp sensor, green and brown. Time switch, green and black. Check it out, green, black. Okay?
Which one was the green and black?
Green, black's the time switch. And then this is my coolant temp sensor to the right. I just wanted to confirm that. And then I really want to get a voltage reading. We're just using a regular voltmeter here, because that's what most of you guys that are driving these cars would have. All right, so what we never want to see on this sensor is 5 volts. 5 volts would be an open circuit. Engine's cold. We should see probably with this temperature, it's about 80 some degrees right now. We should see roughly about 3 volts on this sensor. We'll go one wire to the green first. So 1.75 volts on that one. And 36 millivolts on that one. That's my sensor ground. So the green wire is my sensor signal. And at 1.75 volts, that's not so bad. And what we should see as the car warms up is that number should drop. So what we do to get it started for now, because I want to address this rich condition, not the fact that the cold start injector is not firing, is we'll get the car to fire with this. Go ahead, Beau. Yep. Oh, hold up. Dumbass. Let me restate all of that. The car is not going to start with the distributor plug disconnected. Go ahead, Beau, start it. That should drop as it's warming up. I don't have my equivalents for you right now. Like there's voltage charts you can look at.
For
Temperature to voltage. This is the way you want to check these. A lot of them will have you doing resistance. You don't want to do resistance on these because you could have a bad ground that messes up your signal too. So you want to look at them with voltage.
So what, voltage decreases as temperature increases?
Yep, as temperature increases, voltage decreases. And another way to state that too in this application is this is a negative temperature coefficient thermistor, right? So as temperature increases, resistance decreases. They're opposite each other. And this is a voltage divider circuit. This is chapter 6 material all day long. Lots of theory goes involved with this, but what we don't want to see for rich conditions, clouds of black smoke, is I don't want to see an elevated engine coolant temp sensor number. I don't want to see a real high number. 4 volts, 3.5, 4 volts would be really, really rich condition. We're down at 1 volt, which is honestly surprising to me. I'm surprised we're down that low already. That looks pretty good. Like I said, I don't have a thermometer on there. Really, ideally, you'd want to do that, but at least initially, as far as tracking down this major rich condition, it is not our engine coolant temp sensor that's causing it. All right, so that's one check, coolant temp sensor. You rev it a couple times, kind of watch it still. Okay, airflow meter. How dry rotted this is, so that's doing us no good. We'll do something with that too. Okay, this is gonna be one where all of these are gonna be pretty steady except for one that's gonna move when I move the throttle. All right, we'll start down the line. We'll go with the white and black wire. White, black. 0.13. Steady ground. Green wire. Same thing. That's gonna be my fuel pump switch, those two right there. The other 5, I should have an intake air temp sensor and I should have a potentiometer signal. They share a ground. That's the brown wire. That's my shared ground. The black with the yellow. What we should have left is, we should have another 14 volts on the black yellow. That is not what I expected to see. On the blue wire, 9 volts. Stays the same, stays at 9. And then the one yellow, that's my map signal. See that signal changing? I didn't expect this to be a 12 volt circuit. I don't understand what the 12's there for. Last wire, looks like it's using, well, that's a steady 2. Okay, now I need to know what's what. Main relay, black, yellow, 14 volts. That's the one we read, 14. So that's normal. Then it comes through a resistor and then it back feeds the blue red back to the computer. It says VC. This is different than what I'm used to. The potentiometer signal is yellow blue. What a weird design this is. The brown wire goes to the computer. Pin 12, E21 also is shared here. Brown E2 should be a ground for E2. Yeah, sensor ground. Water temp sensor shares that too. These are all sensor grounds. Brown is a sensor ground. That means the yellow black is the thermistor signal, sharing the ground, the brown wire, with the potentiometer. This is a 12 volt fed potentiometer circuit. How strange. Or battery voltage. So I thought it was 5 volt reference. It's not. But 14 volts coming in here, goes through a resistor, and then it comes out the blue red, back feeds to the computer a signal, a steady signal in the blue red. I think that's the one that read 9 volts. And then that 9 volt drops across this resistor, gets grounded on the brown wire. It's a sensor ground. And then the feedback signal is yellow blue for the Vane airflow door. So it's going to range from 9 volts down because 9 is the feed. And then the thermistor signal is yellow black and it shares a ground here, and then the green and white black are your fuel pump circuit. Weird design for this. Essentially though, this is working. It looks like this is working as it should. Let's go back. Very different design. Yeah, that's my intake air temp sensor signal. That's why it's not changing. Steady. The blue red. I think this is the one that was 9. Yeah, that is basically my reference for this circuit. Steady 9. And then my mass airflow signal is definitely this guy. And being 9 volts is the reference. Did that change on us? So 5.7 with the car idling as I rev it. Goes close to the source, which is 9 volts. And for a rich condition, what you'd want to see is you'd want to see that number get stuck up at the 7, 8, 9-volt number, and that would tell you the door is sticking on you, and that would give you a major rich condition. So right now, the car is not doing that. Whatever we had going on, yeah, I like 5.4 volts. Let's go back to my coolant temp sensor again. 0.54, I like that for a coolant temp sensor reading. Neither of those look bad at all. And your TPS right here. Idle contact switch. That one's 5. Steady 5 on the top. Red wire is the next one. 0.3. That's my TPS signal wire. That looks good too. Blue wire. That's my idle contact switch. So it's 0 with throttle closed. Second I open the throttle, jumps the battery voltage. All right, idle contact switch is working like it should. And then this one's a steady ground, brown wire, shared circuit. So my 3 critical inputs as far as that black clouds of smoke that I saw, they look good right now. I don't see any reason whatsoever for that condition. So what I need to do is revisit these on a test drive to make this happen. All right, let's shut down. We'll move some cars around. We're gonna take Beau for a ride. I just wanna make sure that we have charging system voltage real quick. You get it? Yeah? Okay. What we need is, you gotta get Beau's face, because he's smiling the whole time. Beau doesn't smile often, but he's smiling the whole time. Driving in the Celica, Beau. We're taking Beau down to a parking lot.
I don't want to drive, dude.
Why not? You don't want to be on camera driving?
No, I suck at it.
Everybody else wants to see you drive on camera for the first time. Hopefully we don't get pulled over, because we got no plate, no inspection. It's not even titled in our name yet. I do have car insurance. Technically, this car is not on it.
Okay, so uninsured.
So if we do get pulled over, you definitely got to keep the camera on. It's running good right now, Beau. I wonder what happened. I wonder why it was so rich on us. Like it was really bad. Okay, son.
Don't film my feet because I don't have shoes on.
You're not wearing shoes?
No.
How could you not be wearing shoes? So before you find you're gonna slowly release the clutch till you feel the car start to move, and you're kind of giving it gas at the same time. Yep. That was really good. That was really good. A little faster, go to second. Shift. No, stop. You need the clutch when you're shifting.
Damn it, dude.
Go back to first.
Okay.
Go back to first.
Could you take off in a second?
There's not enough power in this. A little bit more, a little more. Okay, now go second.
Clutch in.
Yep. Keep the clutch in.
Clutch in.
There you go. When your wheels are already rolling, you can let the clutch out quicker.
I don't want to.
Come this way. Watch for cars, though. You still need to watch for cars. Okay, you were coming up on that little intersection. All right, go to first.
Clutch.
Yep. Let the car slow you down. Very good, very good. Now come to a stop.
Come to a stop?
Yeah, panic stop. There's an animal. What'd you do wrong?
I don't know.
Should we make him drive home, Caleb?
No.
I think we should.
Yes. But I want to drive.
Oh, you don't know how to drive a stick either. That's right. I forgot about that. Panic stop.
I really wish I had shoes right now.
You wish you had shoes right now? I bet you do.
Right.
All right, I'm gonna make you drive home. Clutch. You need to push the clutch in when you come to a stop.
Well, this is YouTube. I think you mean to say clutch.
Crap, man.
Shucks.
All right, go ahead. I want to see a nice second gear shift here. Now. Let off the gas.
Sorry.
Let out the clutch. Let the clutch out. There you go. All right, let's get a third.
Okay.
Off the gas, clutch in, straight up, clutch out. Clutch it, yeah.
clutch in.
Yep.
Drifting. With
Yeah, you're already in first before you even come to a stop.
Okay. And then.
Yep.
Dude, this.
So we don't want to do that. That was some major clutch slippage right there. Second all the way up to the stop sign.
No, I want to.
Keep going, keep going, keep going, keep going. Clutch in, drift. You're drifting. Too much brake. First. Should have already been in first.
You told me to go into second, though.
This will be your hardest one. All right.
Okay.
Now, if you were smart, you wouldn't have come to a complete stop because now you made it really hard.
It's a stop sign.
I know, but you could have rolled it. We're gonna be on this hill for a while. No, oh my goodness! Oh my goodness!
Dude, I'm sweating really bad right now. This sucks. This sucks.
Come on, you're good.
What about the hill on
You're good, man. You're going down the hill. We got brakes.
I have to go up first.
That was good. Higher, 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 higher. Yep, now second. Now do it. Do it quick. Okay, when you're already rolling, you don't have to sweat that as much. Just let the clutch out. Okay? Back to first, round the bend in first.
Oh.
Yeah, you still got a brake. Clutch out, clutch out. Why you turn so late?
Nice job, Beau.
Nice job, Beau. Agree. You can just use the car to slow you down. Use the brakes too. So when you use the car to slow you down, do you remember what I said about the fuel injectors?
No.
They shut off. So if you put it in neutral and you're coasting, you still need fuel. If you're using the car to slow you down, injectors shut off on deceleration. So you're saving fuel. And now you can feather the clutch a little bit.
What does that mean?
Feather it. That's not feathering.
I don't know what feathering is.
Okay, well, so now you know that wasn't feathering. Feathering means just where you just feel the engine starting to engage. That's good. That's good. Perfect. That was good. That was nice feather right there. Good job, Beau. Good job, Beau. All right, last thing for the rest of you guys is let me show you the oxygen sensor real quick. We'll wrap this video up. Leave it run, please.